And what I'm going to do is I'm going to just, oops, sorry. I'm going to treat this like like I did on Tuesday, unless, you interrupt me, obviously, or type into the chat if you have other questions. But what I'm going to do is just go over what is new. Um, the content is very similar to what you had in 110, where you still need to know your basic conversions. You still have the same rounding rules. You're doing oral-based medications, injectables, suspensions. But the thing that's different is the flow rate type questions. And so I went over those on Tuesday. I did record that and I uploaded already to YouTube. If you didn't see it, just so you know that it's there. And I'm going to go ahead and focus on those and maybe try and get some additional examples to kind of start things out. If you need to review any of the other questions or have another type of question you want seen, just let me know and we'll certainly go through those. All right, give me 1 second. I always like to start off with a couple, what I consider where's that Ringer's lactate question? Okay. So these questions here, when we talk about flow rate, and I'm going to introduce this a little bit differently than maybe how I did on Tuesday. So when we talk about flow rate type questions, what we're really saying is we're trying to, or what that indicates is some volume over time. And the example I always use, you probably heard me say this before if you watched any of my reviews, is that when we're talking about volume over time, or we're talking about a rate, it's very similar to what you can understand when you're driving in a vehicle, miles per hour, right? So there's a rate, there's a distance over time for speed as far as that's concerned, how fast are you going? For how fast the flow is going, it's the volume over time. And the way you can think about it is if like you can, chug down 20 ounce thing of water in 5 minutes, 20 ounces, 5 minutes. Now you can kind of calculate that flow rate. You would just need to convert ounces to milliliters and convert time to hours. And then you can get what the standard is for nursing flow rate, which is milliliters per hour. Okay. Now, in addition to that, there's a subcategory of flow rates that deal with drops, and these are called drop rates. And a drop rate is going to be written as GTT per minute. And the GTT is the abbreviation for drops. It's not DR because that's the abbreviation for drums, and I think I've said that a couple times already, so I won't repeat myself. So patient is to receive 375 milliliters of Ringer's lactate over 3 hours. What would you say set the rate on the infusion pump to in milliliters per hour? The tricky part of this question is a lot of times nursing students are looking to do more math than needs to be done. And so all we're going to do is we're going to take the volume, and in this instance, it's 375 milliliters over time, which is 3 hours. And we're going to reduce that by taking 375 divided by 3. You plug that into your calculator if you need to, and it comes out to 125 milliliters per hour. So if I want Ringer's lactate to infuse into my patient and I want to infuse 375 milliliters over 3 hours, that's what you're going to plug into the infusion pump or enter into the infusion pump. And then over 3 hours time, they're going to receive that volume of Ringer's lactate. So as a practice, and I'm going to change this up a little bit, let's make this 750 milliliters, and let's make it even more challenging and do 3 hours. No, we already did 3 hours. Let's do 8 hours. So go ahead and do that calculation. See if you can get a flow rate in milliliters per hours. Put your answer into the chat. You can send it as a DM if you don't want to announce your answer to everybody else. If you don't have a problem doing that, then just submit your answer, and then I'll confirm or deny your answer in just a few minutes. All right. So what's interesting is we're getting, we had 3 answers and 3 different answers: 93.75 milliliters per hour, 93.8 milliliters per hour, 94 milliliters per hour. So which is the correct answer? So I'm going to bring you back to our rounding rules. In our rounding rules, there's a couple things to keep in mind. Let me find it. So what's confusing here is the example is they just give you milliliters, but this would also apply to anything that has a volume, including a volume and a rate. Meaning, if you have a volume greater than 1, you should be calculating to the nearest, or rounding to the nearest tenth. So in the example I give, 1.25 milliliters would be 1.3 milliliters. You would round it. If it's 1.24, you wouldn't round it. You'd leave it at 1.2. The same thing would apply for your flow rates. So you still are going to be rounding to the nearest tenth, including your flow rates. Reason being is that's what we're doing in what we call the CCAC math bubble. So you may not do that clinically. The 94 milliliters per hour might be the most correct answer in a clinical setting, but it would be an answer you would get wrong on these dosage calc tests because they're looking for you to round to the nearest tenth, even in your flow rates. So I didn't make up that rule, just kind of following the rules. And then the same thing would be said for volumes less than 1 milliliter. You're going to the hundredths place, not the tenths. But we're not, you shouldn't have to worry about that for flow rates. The only time that you would round to the nearest whole is when we're dealing with drops. And the reason drops around into the nearest whole number is because you cannot give somebody a partial drop. It's either it drops or it doesn't. And so you're going to go to the next highest drop when we do that. And we haven't covered that yet, but that's what that is. So the correct answer for the sample question that I gave you would be 93.8 milliliters. So I'm just going to write that down just so you have that as a reference point for later on. So 93.8 milliliters per hour. So you'd round that to that answer, even if you don't like it. It's not really up to us. It's just following what we're being told. All right. So let's look at a drop rate type question. Oh, actually, before we do that, let's look at an infusion type question where we're dealing with converting minutes to hours. So I left this alone, and I'm just going to go ahead and just leave this alone, and I might change this question up just a little bit. But this says that your patients to receive Ensure 120 milliliters in 90 minutes. Now, the shortcut to this is, and I agree with this shortcut, is convert that to 1.5 hours, right? But if you don't feel confident doing that, or you prefer doing this the dimensional analysis way, you're going to take your volume over your time, so 120 milliliters over 90 minutes, and then you're going to convert minutes to hours. And then that's where you'll get your answer of 80 milliliters per hour. So let's try and do that with something like this. So let's say it's going to be this time 60 milliliters in, let's just say 12 minutes. And I want you to calculate milliliters per hour. So again, go ahead and answer that question, put it into the chat, and then we'll confirm the answer here in just about a minute or two. All right, good. I'm seeing the answers coming in. If you got 300 milliliters per hour, you did that right. Good job. All right, let's look at drop factor. All right, so when we talk about, remember, drop factor is a type of flow rate. So it's just that it's going to be measured in drops per minute. In order to calculate a drop rate, we need two pieces of information. We need to know the flow rate, the volume over time, and we need to know the drop factor. The drop factor will either be given to you, either in the context of the question or written in the question, or there'll be a picture of the label, and you have to look at the label and say, okay, it's 15 drops per milliliter as it says there. Or and you might see this with like ATI, maybe NCLEX later on, is you will get an example of it'll say microtubing, and microtubing is going to be administered by or is going to be the measurement, or the drop factor for microtubing is a standard, and it's 60 drops per milliliter. So it you probably, or I know for a fact you won't see that on your dosage calc tests at Allegheny campus, but you could see it on ATI, and you could see it on NCLEX, which is why I'm mentioning it to you. So if they're looking for a drop rate and they don't give you the drop factor, look for the word microtubing. Next semester, you'll get you'll do heparin and insulin infusions, and they'll call them drips, which technically, with how slow they're going, they are drips, but they're actually looking for milliliters per hour in those situations. So don't count on the fact that it says drip rate, that means that they're actually looking for drop rate. In order, the clue will be they'll give you a drop factor. All right, and then someone asked about how can you give 93.8 milliliters per hour by pump? Well, like I said, I'm not talking about reality, and in a clinical setting, it's just the math. So in the math sense, they want you to round to the nearest tenth. You might be 100% correct that on an infusion pump, you can't set it to a decimal. I don't know that. And I don't know if they're just because they're not in a facility that you've done work in, that they're not in another facility. So I don't know. I don't know the answer to that, other than to tell you that it's based off of the math, not necessarily what you would actually do in a real world clinical setting. So that's why your answer on the math test in this math example would be the 93.8 milliliters per hour, even if it can't technically be programmed into the infusion pump in a real life situation. Sorry, that's the answer I'm going to give you, because that's also the answer that I've been told. So, all right. So with drop factor, like I said, you need two pieces of information. You need to know the flow rate, and you need to know the drop factor. Okay. The drop factor will be given to you. It's in drops per milliliter. I always say that the drop factor is basically your conversion factor. It's basically the same thing as saying 125 milligrams per 5 ml. It just tells you what the what the factor is. Now, flow rate, I used to tell you milliliters per hour, which is the technical, flow rate. But when we're dealing with a drop rate, what we're really looking for is milliliters per minute. The reason I'm saying that now, as opposed to how I've said it previously in the past, is because it is a way to kind of focus on, if it's already in minutes, leave it alone. If it's in hours, convert those hours to minutes first, then go into the rest of your calculation. And we'll do an example of that down below when I change up that question. So when we do this, okay. So somebody's asking if the okay. Yeah, I don't know if he's going to even hear this, but we're not paused live. All right. I don't even know if they'll get that. So anyways, and don't worry if you're catching this later. I have recorded it, so, or I am recording it. So okay. So if you're doing dimensional analysis, you're good to go. Okay. Yeah, somebody had typed into the chat via DM, and so I knew we weren't paused because I was getting questions asked in the chat. So okay. So what we're going to do is we're going to calculate our flow rate by taking our volume, which is, in this example, is 75 milliliters, over our time, which is 25 minutes. And then I'm going to multiply by my drop factor, which in this instance is 15. And all I'm doing is dimensional analysis. So if you're doing this using dimensional analysis, you're getting the right answers. If you're doing it a different way, but you're still getting the right answers, you're doing it right. I'm not here to tell you otherwise. Okay. So just for consistency's sake, and then this answer would be 45 drops per minute. So let's practice one. I'm going to give you this question here, and I'm just going to clear this out, and I'm going to change the variables. So that way we'll leave that alone. All right, so for this example, we're actually going to use, we'll use 25 as the drop factor. And it's at, let's say, 500 milliliters. And we're going to say 6 hours. And I want to know what the flow rate is in drops per minute. So I've changed the factors for this one. That says it's 17, but I'm going to delete the number there. So it's a separate question. Go ahead and attempt to answer that question. 25 drops per milliliter is the drop factor. Flow rate is 500 milliliters over 6 hours. See if you can get the drop rate. Okay. And I'm seeing the answers starting to come in. If you got 35 drops per minute, you did it right. So if you're not getting that answer, please let me know so I can kind of figure out how to help you out. And you can just send me a direct message and just say, hey, I'm not getting that answer, or I keep getting such and such answer. The real answer you should have calculated was 34.722222222. But as we mentioned previously, at least when it comes to drops, we can't give a partial drop, right? So we have to round to the nearest whole drop. If that answer was 34.222222, we would just leave it at 34 drops. But because it's 0.5 or greater, we're going to round it up to 35. All right. The next type of question is these how long will the infusion take type questions.
Can I interrupt for a second just to ask you a question?
Yeah, go ahead.
Okay, so I got the answer right,
Good.
but I'm curious how you would set it up. I started with 500 milliliters per hours, and then I converted the hour in 1 hour over 60 minutes, and then times 25 drops over 1 milliliter. Is that how you would have started it, or would you have started it with the 25 drops over 1 milliliter?
So I would have I always start with the flow rate. So like the order I've mentioned previously is I do flow rate times drop factor. And so what I would have done is I would have done 500 milliliters, but I would have done 6 times 60 and did 500 milliliters over 360 minutes is the only thing I would have done differently. But what you did is perfect. So I just would have did it. I would have started um, by converting hours to minutes as like a pre-step before I even did any dimensional analysis.
Okay, all right. I mean, I got the answer right, but if I like to be able to like always use the same pattern so I can never get lost.
No, that's fine, and you're doing them right, so don't change anything on my account. I My point is to let you know that there's several ways to get to the same answer, and what you did was correct. So your whole setup was perfect. I wouldn't change anything on it.
Okay, thanks.
Yeah, you're welcome. All right. Yeah, and then just for again for clarification, you if you answer 94 milliliters per hour when the answer is supposed to be 93.8 milliliters per hour, it will be marked wrong. Um, because technically you can give somebody a tenth of a milliliter. You can give somebody a thousandth of a milliliter if you have the tool to administer it. So you know that that's a true thing when it comes to injectables. You may know that that's a true thing from a the standpoint of a infusion pump, but I wouldn't necessarily say that is a definitive thing because there is a possibility that if the infusion pump can get measured down to the tenths, you could program and then be more correct. You might even be able to program it to 93.08 milliliters per hour if that's what it came down to, if that's what you had available to you. Does it make sense in the grand scheme of things? Is there much of a difference between 93.8 and 94 as far as the medication being administered for an adult? No. But for a child, there might be a significant difference. I doubt it because the number's so big, but I'm just telling you based off of the math rules at CCAC that the correct answer for a milliliters per hour, you would round to the nearest tenth. The reason, and the reason being is because you can give a tenth of a milliliter. That's actually very easy to do. It just may not be easy to do on an infusion pump. On a drop factor, though, you can't give a partial drop, just like you can't give somebody a partial capsule, right? If I cut a capsule in half, you're not getting 50% of the medication in half the capsule. Because if you ever opened up one of those capsules, there's a bunch of little pellets in there. You don't know if you're getting, an equal number technically. Would it matter too much for an adult dosage? Probably not, because you're probably getting enough in the half, and then you're taking the other half, I'm assuming, at some other point. But you can cut a tablet in half, right? Because tablets can be scored, and you can cut a tablet in half and then give somebody a half tablet. So it's nuance, but I just want to make sure that you're following the rounding rules. Again, I didn't make those up. I'm just telling you as they are. So make sure that when you are doing flow rate questions, if it's in milliliters per hour, you could potentially have an answer that's in you could have an answer that's like 7.5 milliliters per hour. 89.3 milliliters per hour. You may not like it, but that is, and it may not look right, but that is what the right answer is. And hopefully, whomever writes your test, it should come out where it's like an even number, and you don't have to worry about rounding. But I'm just letting you know that that's the correct rate around your flow rate questions. Drop rates round to the nearest whole drop. flow rates round to the nearest 1/10 of a milliliter. All right. So let's look at another variation of flow rate before I move on to reconstitution. This is how long will the infusion take? Okay. So a lot of times when they're asking this question, they want to know how much time before the bag runs out of fluid. So in this example, we have 500 milliliters of an IV. We already know the infusion rate's 125 milliliters per hour, and we want to know how long will it take. Now, sometimes they're going to ask you that question, and they'll be a little bit more specific. They'll say, how many hours will it take? What is the specific time for the start and the stop? Or it'll ask you more or let's say how many hours and minutes. So for this one, let's just see what it comes out to. If I take my volume and then I cancel out volume, I'm going to be left with time. 125 goes in the 500 4 times. So this particular situation, it'll be a 4-hour infusion. Okay. Now on Tuesday, I had somebody ask me, well, what if we get a decimal answer? How would we calculate like hours and minutes? And I'll show you how to do that here. But let me just give you another scenario. Let's say this is 750 milliliters, and this is 150 milliliters per hour. Go ahead and calculate how much time, and just go ahead and do to the hour. So if you get like a decimal answer, it's perfectly fine. Go ahead and do that calculation and see how much time will this infusion take if it's a 750 ml IV infusing at 150 milliliters per hour. Good. So those of you who are getting 5 hours, that is correct. So all you would do is take 750 ml, divide by 150 ml per hour, and you're going to get 5 hours. Now, what if you got something like you might be able to figure this out? Like if, so let me just write like, so instead of giving you actual things, so like, let's say you got something that gave you hours and minutes, and you wanted to know the actual time. So like, let's say you got an answer that said like, let's say it said 3.65 hours. So I'm using that. This is not necessarily going to work out clearly, but it should be fine. So we know that we have 3 hours that has elapsed, but we need to figure out how to calculate minutes out of that 0.65 hours. So the shorthand on that is this is going to be written as 0.65 hours, and you're just going to convert hours to minutes. So I'm going to be multiplying by 60 minutes. And what I'm going to get is 0.65 times 60 will actually give me 39 minutes. So my total runtime in this 3.65 hours example would be 3 hours, 39 minutes. So let's say, as another part of the example, let's say we started this at, 10:15 a.m. What time would it end if it's going to run for 3 hours and 39 minutes? So this is a challenging one. We'll see if you can do that. See how well your clock skills are. So take a minute and come up with an answer, put it into the chat. And if you just don't know, you just put a question mark. That's perfectly fine, and I'll show you what to do. All right, I'm seeing the answer that I also got. So you might need to answer that in military time, which would be the 13:54, or in the standard time, which would just be 1:54 p.m. And all I did is added 3 hours, and I imagine what Yvonne and Christine did is you added 3 hours to the 10, added 39 to the 15, and then you made sure that because we went to the next, right, we went past noon, and so that's how you would do like a start end time. So if you get a question or you see a question on ATI and it says something like, the infusion starts at and ends at, or it's asking you like if it started at 10 a.m., when would it end? That's how you would answer that question. So hopefully that makes sense. All right. So go ahead and look over the rest of the practice test. If you have any questions you want to see answered or work through, just let me know. Oh, I did say the reconstitution question. Sorry. So there is a newer type of reconstitution question that's coming down the pipeline. So you might see it next semester. You might see it fourth semester. You might never see it. But this is the reconstitution question that has been asked at like some of the other campuses over the years. Your reconstitution questions are these up here. So they're basically the same thing. It's just a different version of it. The thing that makes this different is you have to search the instructions in order to find um, the information that you're looking for, which is the strength of the medication. So in this example, even though it says clearly 500 milligrams, because this is intramuscular, you know that means it's that your final answer is going to be in milliliters. And what you should be picking out when you look at this is saying like, hey, it doesn't say anything about milliliters here. It just says 500 milligrams. So do I assume that it's 500 milligrams per milliliter? Please don't do that. That's not how this works. You need to actually look at the directions, and it tells you specifically what the concentration is after it's been mixed. So as you can see here, it says they added 2 milliliters of sterile water. It gave a total volume of 2.2 milliliters for a actual concentration of 225 milligrams per milliliter. Once you know where that information is, or at least now you know how to look for that information, then you can go on and carry on with the rest of your calculation. And then and I worked this through on Tuesday. I converted 370.375 grams to milligrams. I just moved the decimal point over. 375 over 225 times my quantity is 1.7 milliliters. As long as you got 1.7 milliliters, you're doing it correctly. If you use traditional dimensional analysis, like Christine, I know you like to use, or I showed you here, ordered over available, and then that's what that would look like. Just want to double check something. No, that's all I wanted to say. Oh, and I was going to add that for the reconstitution question, like this question in particular, I have a separate YouTube video where I've walked through this and maybe one other example. So you can look at that if you need to see that. Again, I don't anticipate you're going to see a question like this on your actual test next week. I just wanted to let you know that that you might see it later on and at least show it to you what it looks like. All right. So, first of all, I'll just ask either, and you can either type it into chat or just let me know, what did you get as a final answer? Okay, so tell me what you tried to do, so I have an idea of where, how I can help you. And if this is your first, and if you want to try it now, go ahead and try it now, and let me know what you're trying to do, so I can um, see how to help you answer the question. And for those who have already answered this question, go ahead and see if you can get an answer for the new one I did 75 milligrams Visceral, 90 milligrams Mepridine, and I want to know the total volume for the combined injection utilizing the two labels listed above. And then just when you get an answer, just go ahead and put it into the chat. So good. I'm seeing the answer here for the second one. The second example is 2.7 milliliters. So if you're not quite sure where to go with this, remember you've already done these problems hundreds of times, right? It's just how many milliliters of Visceral, how many milliliters of Mepridine, add them together.
I didn't think it could be that easy. So, um, I was, so I was looking for the trick or what am I supposed to do? Because I thought, don't I just add them together? No, that'd be too easy.
Yep, that's all you do. Because that's all that it's asking you to do, right? It says, what is the total volume? So basically, you're doing like, it's almost like you're mixing insulin, right? But instead of adding 20 units and 30 units for 50 units total, you're doing milliliters of Visceral, milliliters of Mepridine, and then you're doing that combined injection. And then just make sure you round to the nearest tenth. So like when you do the first one, the answer key I think says 2.3 milliliters because you get 1.2, and then I think you get 1.111111 or something like that. I can't remember. So if I take 60 divided by 50, I get 1.2. And if I take 85 divided by 75, I get 1.1333333. And you just add 1.2 to that, you get 2.3 repeating, which is why you get an answer of 2.3 milliliters for 24. So what are we doing? So if I'm doing order over available for Visceral, and if I'm doing order over available for Mepridine, that's where I get that 1.1333, and that's just repeating. Then we just add 1.2 to 1.13, and we get 2.3. And it's the same thing we did in the second example, just that you didn't have to worry about rounding. Good question. Very good question.
A lot of the stuff on there, I can like read it and I'm like, oh, I just divide this by this. But I get worried because it's like if I don't do the formula, what if the test is more complicated and then I get screwed up because I didn't do like a formula? Should I be fine, or should I like stick to using the formula stuff?
So are you, I don't know what you mean by formula, but if you're getting the right answers with everything, and even the other examples that I'm showing you, and you're doing it a particular way, you're doing it right. And your test is going to be very similar. The only thing that's going to be different is it's going to be maybe a different medication. So maybe instead of Visceral and Mepridine, it's two completely different medications, but they're still injectables. And as long as you know how to do either ordered over available times quantity, or you know how to do dimensional analysis and you're getting consistent answers, you're doing it correctly. So the only thing that, like I said, it's going to change is what the label says and then the orders, right? And that's consistent through all these questions. So like that Ringer's lactate question, if you can do 375 over 3, get 125 milliliters per hour, perfect. However you're doing that, as long as you're getting that right answer, you're doing it correctly. And then the only thing they're going to change is they might say, oh, it's 500 milliliters over 4 hours. That's the nuance. But this is the level. These practice tests were designed with the actual tests in mind.
Okay.
Yeah.
All right. Thank you.
You're welcome. I don't know what you mean by multiple type of questions. I don't understand the question. If you're asking, do you need to show your work? If it's on paper, yes. And I think even if it's not on paper, they're going to have you, they're going to collect your scratch paper. So you do need to show your work. But like I've said over the years to students, I don't know what that specifically means. Meaning, like, do you need to show dimensional analysis? Do you need to show that you followed a formula? I don't know that specifically what they're looking for. I think they just want to make sure you're not cheating. Although some of these questions, like especially like a BID question, like 500 milligrams BID, it's available at 250 milligrams, so you're going to give them 2. Like, you probably don't need to write anything down math wise to answer some of those questions. But if you want to be on the safe side, make sure you're writing something down. I think they just care that you're not cheating more so than they care how you got to the answer. But I'm not 100% certain on what you're supposed to be showing or not showing as far as that's concerned. Analysis.
Yeah, that's why I was asking you because I'm totally stuck. Let me think. Patient ordered. So I guess I would do them probably as two separate dimensional analysis. First with this visceral. So it would be 50 milligrams, or I would do 60 milligrams over one. Oh, I don't know.
You're
I
doing
think
it
I'd
right.
start with 50 milligrams. I am.
Yeah.
All right.
Yeah.
All
Start
right.
with your order, 50 or 60 milligrams over 1.
Okay, 60 milligrams over one. And then I'd multiply it by 50 milligrams. No, I wouldn't. One over.
You got it.
Is that right? One over 50 milligrams?
Mm-hmm.
No,
1
one
milliliter over
milliliter.
50 milligrams. Right,
Okay,
because what is
milligram.
your conversion factor? It's 50 milligrams per milliliter.
Right. Okay, so, and then that should just 60 divide, gives me the same thing, 1.2. And then I would do the same thing with the other one. So basically it's the same thing.
Correct. Yeah.
Ordered, yeah, all right.
So
All right, it's just,
all order over available is just a reworking of dimensional analysis. So all you're doing is moving the instead of it being like two, like this over this times this over this, you're just putting the numerator and the denominator for those two different variables together, and it's just another way of writing the same thing. That's why I asked you to talk it out to me, because I knew you could do it. I just wanted to hear and then to confirm that you could do it. So, because I knew you could.
Yeah, thank you for doing that.
Sure.
And actually seeing them side by side, I see, yeah, it's exactly the same thing, only kind of shortened on the ordered over available.
You got it. Yeah, and I would say, like, for most students, or I would say over the years, most students do use ordered over available. The only time it becomes a problem is when they start doing like some of the flow rate questions, because your available, it doesn't make sense, especially when you only have two variables like volume and time. There is no order over available. It's just what is the flow rate. So, but you're doing it right. So, um, and then for the question about insulin, so I have it here. First of all, what I wrote there and then highlighted in yellow, I'll always recommend that you write that down, especially if it's a paper test, so that way they know specifically that you have the solution, regular, the amount, 10 units, and that it's going to be drawn up first, and that you write your correct total medication, 50 units total. Then when you mark your syringe, the first mark I'm going to make is on the total. I'm going to add my my two things up. Regular is 10, NPH is 40, so 10 plus 40 is 50. I'm going to mark my syringe at 50. Then I'm going to, from the total mark, I'm going to deduct whatever my regular insulin is. The 10 units regular insulin is why I'm making a mark at 40 as opposed to making a mark at the 10. The reason being is because once everything's been mixed together in a hypothetical situation, and again, this is where things don't necessarily match up clinically, you could say that the regular would exist closest to the plunger side of your syringe, and then the NPH would be closest to the needle side of your syringe, which is why you are to mark it somewhat like this. So notice I did more than two arrows, but I want to make sure whomever's grading this knows that I know that my regular is between 40 and 50, that the NPH is between 0 and 40, and and then there is where I got this from, a textbook that explains, and that's in the OneDrive folder as well. You'll see like mixing insulin syringes. You just click on that PDF and you'll see the picture that depicts how you're supposed to mark your syringe. So
That's a trick question because I guess the your inclination would be just to mark the 50 and move on.
well, it would probably be to mark the 50 and then mark the 10, is usually what students end up doing over the years. But what they want you to do is mark it like this: 50, 40, indicate that the regular is between 40 and 50, and that your NPH is between 0 and 40. But I would just say it's just a nuanced question that's not math, but they do want to make sure you can mark a syringe. I think that's the more important thing.
So we just have to remember clear before cloudy, regular is clear, NPH is cloudy. And so we would put no, we would do cloudy before clear. Is it clear before cloudy or
it
cloudy
is
before clear?
it's always regular first. So, and regular is clear.
Oh, okay.
Yeah.
Clear before cloudy. Okay.
Yeah. So as long as you remember regular first, because it's never going to be listed as clear or cloudy, but regular is clear. So regular first.
Okay. I'm going to put that in with my know your conversions.
Mm-hmm. All right. So I need to jump off to prepare for the next section, but I will be back for a 1:30 review at 3:45. If you come on, then I'll be on then. If not, good luck on your test.
Thank you. I won't be back because I can't, but thank you. I've attended 3 of these and they really help.
Okay, good. Yeah, I hope you found it helpful, Christine. Thank you for the feedback.